Hi, everybody. My name is Josh Mello, Worldwide Storage Specialist for S3. Thank you for joining us here today. We're going to spend the next hour talking about how to move data archives to AWS to lower cost and gain new insights. Joining me here today is Eric Bowman. He's a senior storage solution architect for S3. He builds solutions for our customers. So today we're going to talk about some common archiving challenges. We're going to talk about AWS solutions for archives. We're going to dive a little bit deeper into the S3 Glacier storage classes. Eric's going to spend some time talking about how to operate at scale with Amazon S3 and Amazon S3 capabilities. We're also going to dive into some archive solutions that our customers are using and wrap up with some additional resources to help you learn more about our archive solutions. So when we talk to customers, we see some common themes in terms of the overall challenges that they face when it comes to cold storage and archive storage. We believe that archive storage is just data that's not being used at the present moment. So archiving data on premises is very difficult. Hosting data in general comes with its own set of challenges in a traditional data center. So customers who are managing all their on-premises storage, typically they build out a secondary data center location for redundancy and resiliency. This increases the overall cost profile and overall complexity. Managing this across a global footprint can also be extremely complex and extremely cumbersome. Customers are also frustrated at the fact that their on-premises storage really is built out across different silos. There are siloed data sets based upon the infrastructure that was rolled out. Many customers have disk-based systems, tape-based systems. Each system basically ends up being its own island of data where they can't leverage insights or data across those assets. Many of our customers also come back and complain about the high-touch approach of managing storage on premises. Every 3 to 4 years, customers are having to migrate data from one set of infrastructure to the next upgraded system. It's a constant 3 or 4 year cycle that customers have to go through. They pay for that, the very costly data migrations moving from platform to platform. By moving to AWS, you can just move once and not have to worry about migrating every 3 or 4 years. Many of our customers are also still using tape infrastructure, which is often very burdensome and very costly to have to maintain and have to worry and always update and upgrade media, as well as the actual tape library infrastructure. There's also the inherent security risks when moving physical storage devices, such as tape, moving them via third-party courier, moving them across town or across the city to a vaulted third-party location. It's extremely complex and adds an additional profile of risk that most customers are looking to get away from. So we believe that AWS is the best place to archive your data, and we've really doubled down on the archive capabilities that we offer over the past several months. We introduced a brand new storage class at reInvent called Amazon S3 Glacier Instant Retrieval. This is really designed for long-lived archive data that requires milliseconds level based retrieval. It's designed for data that's accessed very rarely, but when it's accessed, it needs to be brought back and accessed immediately. We built S3 Glacier Instant Retrieval using a multi-AZ approach and design, supporting 11 nines of durability. S3 Glacier Instant Retrieval is designed for 99.9% availability with a 99% availability SLA. We deliberately designed it to have the same performance as the S3 standard storage class. When we talk to customers, there are often a wide range of use cases that customers are using for this storage class. We work very closely with our partner community, and we see great adoption from ISVs, including data protection ISVs. We're supporting this for backup and data protection workloads. We see a lot of consumer-facing applications and web-based systems where data is stored indefinitely, but when it needs to be brought back, it needs to be brought back immediately. So customers are looking for the most cost-effective approach. They want the economics of an archive storage class, along with the ability to bring it back immediately. So this is one of 3 storage classes that we've built out to support archiving operations. So taking a closer look here, S3 has a wide range of storage classes, and with all these storage classes, you have the ability to choose which one is right for your application based upon the balance of performance, availability, and cost requirements. So let's take a closer look at the 3 archive storage classes that we have built out here. So as we mentioned before, we've got S3 Glacier Instant Retrieval that was recently launched as a very compelling price point. It provides instant retrieval. You are performing a get operation to bring back your data and bring back your objects. We also rebranded S3 Glacier. So S3 Glacier is now known as S3 Glacier Flexible Retrieval. We also lowered that price point on a per gig per month basis. We also included in free bulk retrievals. So when we speak with our customers, we often find that many of our customers are using S3 Glacier Flexible Retrieval for data protection workloads, backup workloads, DR workloads, and now they're able to use S3 Glacier Flexible Retrieval with free base retrievals to allow them to have a better cost profile and more predictable profile for bringing back their data. S3 Glacier Flexible Retrieval provides 3 data retrieval options, including expedited, which brings data back within 1 to 5 minutes, standard, which brings data back in 3 to 5 hours, and bulk at 5 to 12 hours. We also have S3 Glacier Deep Archive that is really ideal for previous data that was on premises in tape-based archives. We see a lot of customers moving away from that on-premises based tape and moving to S3 Glacier for a very, very aggressive price point at roughly $1 per month per terabyte. So customers have the option to retrieve data with standard, which brings back data within 12 hours, and bulk within 48 hours. Many of our customers are using S3 intelligent tiering. We've made some recent enhancements by adding in archive instant access tiering capabilities. So the same capabilities that are found in S3 Glacier Instant Retrieval are now built into S3 intelligent tiering. So this is enabled by default. When we take a closer look at how intelligent tiering is used, when data moves into S3 intelligent tiering, we're monitoring which data, which objects become hot and actually accessed frequently. So data that's not being accessed can actually tier down after 30 days into the infrequent access tier. After 60 days, subsequently, a total of 90 days, if that object hasn't been accessed, it can tier down into the archive instant access tier automatically. So we're actually moving that data automatically so customers don't have to worry about that. And we're finding customers can now save up to 68% with this new archive access tier. This happens automatically. We also have 2 optional opt-in tiers called the archive access tier and deep archive access tier. Many of our customers use S3 intelligent tiering when there are unknown or perhaps changing data access patterns. So it really allows them to ensure that they're moving their data into the lowest cost access tier possible. We're managing that so they don't have to. We take a look at the broader range of S3 Glacier storage capabilities here. Many of our customers who need that milliseconds-based retrieval across all their application workloads, but are looking for that cost-effective economic point, they are balancing that and leveraging S3 Glacier Instant Retrieval. It's providing that instant retrieval for that rarely accessed data. Many of our customers, and Eric's going to spend some time drilling into this a little bit later on here, are leveraging S3 intelligent tiering for their data lake strategy. Many customers are basically looking to save their data sets and make sure they're placed on the most cost-effective access tier, and they're doing that with S3 intelligent tiering. Many of our customers for data backup and data protection are using S3 Glacier Flexible Retrieval for free bulk retrievals. And of course, customers are leveraging S3 Glacier Deep Archive really to ensure that they're getting the lowest storage cost for compliance records, for video footage, historical data sets, and ensuring that they have those assets to run analytics or gain data insights from them when they need them. It's really a great insurance policy so that when their business needs those insights, they can leverage those, leveraging other AWS services. Next, Eric's going to talk about how to operate at scale, leveraging Amazon S3 and S3 capabilities.
Okay, thanks, Josh. Josh did a good job of going over some of the kind of business drivers, why you might want to move your archive workloads to AWS and use Amazon S3. Talked a little bit about the storage classes, but I want to pivot a little bit and talk about some of the critical components that you may be worried about when you're moving your archive workloads into a cloud environment. The first one I want to talk about is data durability. So S3 is designed for 11 nines of data durability to protect your data in the cloud. What that means is if you store 10 million objects with Amazon S3, you can, on average, expect to incur a loss of a single object once every 10,000 years. So that's pretty durable storage for your archives. The AWS global infrastructure is comprised of 81 availability zones with 25 geographic regions around the world. This means that you have global availability, globally available storage whenever you need it. There's no need to provision anything in advance, and you can just start using it when you need it. You no longer have to worry about running out of capacity or over provisioning storage. over provisioning storage appliances on your on-premises environment. An AWS region is a physical location located around the world where we have clusters of data centers that we call each group of these data centers availability zones. Each of our regions is architected with multiple availability zones separated by many kilometers. They're all designed to withstand concurrent failure of multiple physical infrastructure components, enabling us to achieve the high level of durability we have with S3. So with S3, you don't need to think about maintaining your own on-premises fleet across several geographies to protect your from failures or disasters. Our architecture in S3 and Glacier really are designed from the ground up with data durability in mind. We redundantly store your objects on multiple devices across a minimum of 3 availability zones in an Amazon S3 region. Each AWS AZ has independent power, cooling, and networking and is connected via redundant ultra-low latency networks. This gives us the ability to tolerate concurrent device failures and even the unlikely loss of an entire availability zone without impacting the availability of your application or losing your data. And you get these resilience and availability characteristics without having to do anything specific on your end. In fact, when you give us an object, we store your data in this durable way before we return a success message back to your application. We handle all of the heavy lifting behind the scenes so that you can focus on building your applications. In addition to the architecture of S3 and Glacier, another important aspect of delivering 11.9's of durability is what we call our culture of durability. Every time we make a change to production systems or introduce a new feature to customers, we take that change through a durability review. This is very similar to what many of you do on the security side, where we examine threats and durability, both real and hypothetical, and we don't launch anything until these threats are mitigated. We also do integrity checking to the point of paranoia. Whenever we move data around in the system, we also use checksums to verify that data remains as we expect to be throughout its entire lifecycle. And finally, we check and recheck data at rest. We have independent fleets of auditors that crawl S3, searching for any data that may need repair. So next, I want to take a look at S3 replication. So replication is an automatic process that makes identical copies of your data. S3 replication retains all metadata that is on the source object, including the object creation date and time, as well as the version ID. From the data protection perspective, S3 replication lets you create copies of your data sets to provide business continuity and disaster recovery protection. You can replicate from a single source bucket to multiple destinations in the same AWS region with same region replication, or to different regions with cross region replication. We also have two-way replication of object metadata. This way you can create shared data sets across multiple regions and keep all object metadata in sync between buckets. And if you need predictable replication backed by an SLA, S3 replication time control lets you replicate objects within 15 minutes of upload. This helps you define a 15-minute recovery point objective for those critical workloads you may have. And lastly, S3 replication also helps you replicate data to buckets with with retention controls enabled via S3 object lock. So S3 object lock, when we talk about the factors to consider when defining data archiving strategies, compliance requirements are often top of mind. So in your organization, if you have a requirement to enforce the retention of an object, either for internal data protection or for regulatory compliance, you can use S3 Object Lock. S3 Object Lock is an S3 feature that blocks object version deletion during a configurable retention period. It is enabled at the bucket level and is configured at the object version level, either by defining this configuration during the put operation of the object, or by leveraging the default configuration you've defined for your bucket. It allows administrators to define retention policies that can control if and when the data is eligible for deletion, offering a write once, read many, or worm compliant storage solution. Object lock configuration is retained if the object version is life cycled to a different storage class for cost optimization, or if it's being replicated using same region or cross region replication. Object lock status, including the retain until date, can be obtained on a per object basis using the head object API, or this information is available at scale via the S3 inventory reports. S3 object lock can be configured using two different modes: compliance and governance mode. Governance mode is for customers that have workloads requiring write once, read many protection, but also want the flexibility to modify the retention date if needed. With governance mode, using user accounts such as the root user are able to modify any object's retention date, allowing for immediate object deletion. In compliance mode, however, there are no user accounts that can shorten the original retention date. This mode is generally leveraged by customers that have strict government or industry regulations that require data be retained for a set period of time. Additionally, there's the legal hold setting, which can be enabled on an object to ensure even if the configured retention period has passed, the object will remain immutable. This is useful should an event such as an audit require objects that may soon pass their initial retention period remain protected until the completion of that event or audit. The legal hold is a feature that's completely separate from the mode and retention period. So, for example, if the retention period is set to expire in a year from now, and you enable legal hold for, say, a week, and then remove it, the retention period will still remain for that object until the original retention date. So you can kind of enable and disable that legal hold feature. Regardless of the configuration of the retention period of the object. Next, I wanted to talk a little bit about data encryption with Amazon S3. Um, First, just want to point out that for sensitive workloads that require client-side encryption, AWS does provide an encryption SDK that can be used to facilitate encryption prior to transmission to S3. And of course, you can also encrypt your data with a third-party encryption tool if you would like as well. Um, Next, S3 also provides TLS encryption to protect your data on the wire while it is in transit to your S3 bucket. So TLS encryption is enabled by default if you're transmitting your data using the AWS provided SDKs or the AWS CLI. But it is an option that can be disabled. So to be sure that your data that is written to your S3 buckets leverages TLS encryption, we recommend using a bucket policy configuration that can reject all connections to your bucket that are not leveraging TLS. Additionally, S3 offers several server-side encryption options to protect your data at rest. The first option is called SSE-S3. This option is completely managed by the S3 service and does not require any integrations with any other key management systems. Um, the next option is SSE-KMS. Um, SSE-S3 works great for many workloads, but um, for some workloads, you require some more control over the encryption keys and key rotations. So for those workloads, we recommend using SSE-KMS. SSE-KMS leverages the AWS KMS key management system to manage user access and key rotation policies. And finally, we have SSE-C. This option allows customers to manage their own encryption keys and include this key during put and get operations to S3. In this case, the S3 service will require the key be included in the header each time a customer wishes to interact with their data. So S3 uses this key to encrypt the data, but does not store this key anywhere. When using SSE-C, it's crucial that proper care is taken to ensure the encryption key is not lost, as AWS has no ability to decrypt your data without it. One thing to note, SSE-C also causes some issues when you're using services like Replication. And if you're trying to use your service, I'm sorry, your data in other data lake applications within the AWS infrastructure, because we have no ability; those applications have no ability to decrypt your data. So it does limit the insights you can gain from your data if you store using SSE-C. So another key consideration when choosing an archive solution is data integrity validation. So S3's put object function previously allowed you to pass the MD5 checksum of the object and only accept the operation if the value that you supplied matches the one computed by S3. While this allowed S3 to detect data transmission errors, it does mean that you need to compute the checksum before you call put object and then after you call get object. Additionally, computing checksums for large multi-gig or even multi-terabyte objects can be computationally intensive and can lead to bottlenecks. In fact, some large S3 users have built special purpose EC2 fleets solely to compute and validate checksums. So recently, S3 has released support for 4 new checksum algorithms. It is now very easy for you to calculate and store checksums for data stored in Amazon S3 and to use the checksum to check the integrity of your upload and download requests. You can use this new feature to implement the digital preservation best practice and controls that are specific to your industry. In particular, you can specify the use of any one of 4 widely used checksum algorithms: SHA-1, SHA-256, CRC32, and CRC32C when you upload each of your objects to S3. At the end of the day, if you want to speed up the process by an order of magnitude or so, you probably need to figure out how to parallelize it. And that's what we've done here. We have introduced 2 optimizations for integrity checking that together can accelerate your integrity checks by up to 90%. The first thing we did was to enable you to pass in the checksum as a trailer instead of as a header. Now, this might seem subtle, but has a huge impact. It means that we can calculate a checksum as you stream the bits to S3 and then just tack that on to the end of the request instead of having to process that checksum prior to any bits being transmitted over the wire. The second thing that we did was enable customers to break up large objects into parts and then to check some of those parts in parallel. We enabled this both on upload and later on if you want to come back and check some of the object at rest. This is a big deal because it means that you don't have to sequentially process a huge object that could be terabytes in size. You can break it up and farm that work out to many cores, all working in parallel to check your object. To simplify checksum retrieval, a new get object attributes API function has been added. When you use this get attributes API, it will return the checksum for the object, and if applicable, for each of the object parts. So we talked about all the great ways that S3 can provide a secure, redundant, and durable platform for storing your archive data. But why not take that one step further? If you really want to harness the power of your data and put it to good use for your company, you need to build a data lake. Um, S3 has hundreds of thousands of data lakes running on it today. S3 holds more than 200 trillion objects and averages over 100 million requests per second. 200 trillion objects is equal to roughly 26,000 objects per person on Earth. Um, Customers have saved more than $250 million in storage costs by using S3's intelligent tiering storage class in their data lakes. And at reInvent last year, we announced two new capabilities for Lake Formation. First, the first is row and cell level security. It allows you to restrict access to data in your data lake tables for specific columns in certain rows for those columns. Lake Formation automatically filters data and only reveals data permitted by your policy or authorized users. The second one is transactions for governed tables. It provides full autonomy, consistency, isolation, and durability, or ACID guarantees, when adding or removing multiple files and tables in your data lakes. To make it easier to get your data lake up and running in just days, we created AWS Lake Formation. So Lake Formation helps you collect and catalog data from databases and object storage, move the data into your Amazon S3 data lake, clean and classify your data using machine learning algorithms, and then secure access to your sensitive data. Lake Formation gives you a single place to enforce access control and operate at the table and column level so that all the users and services can access your data in the right way. This is incredibly important, especially when you want to give multiple teams, applications, and tools access to your data. Take, for example, sales data. Not everyone needs access to all your information, nor should they have it. You might want to you might want account managers in France to see only French accounts, or the marketing team to see only accounts within marketing with marketing activity. And you probably want your finance team to have access to everything. To give customized access to slices of data, traditionally you've had to create and manage multiple copies of data, keep all the copies in sync, and manage complex data pipelines. It's a lot of heavy lifting. And AWS Lake Formation can ease that burden, freeing up resources to work on things that truly move the needle for your organization. And looks like now I'm going to hand it back over to Josh to talk about some industry specific use cases and customer activities.
Thanks, Eric. Next, we're going to take a closer look at how industries are using AWS to archive their data. So, taking a quick look at this slide, there's a wide range of industries and verticals shown here: media, entertainment, financial services, healthcare, science, research and technology, manufacturing. These are all very different industries, but they all have one thing in common: that they all trust AWS to store their archive and cold data. We take a closer look at the wide range of use cases. Taking a look at the media entertainment space, there's a wide range of use cases such as broadcast archiving, media archiving that really needs to be stored for years and decades. But in many cases, it needs to be brought back instantaneously. So that's really a great fit for S3 Glacier Instant Retrieval. And we see customers using it in that space. We also work with a wide range of customers across all these industries, including automotive. So many of our automotive customers are building out data lakes on S3. They're leveraging S3 intelligent tiering to ensure they've got the right cost profile for their data sets. We also work very closely with customers across financial services industries, as well as healthcare. These are two regulated industries that are taking advantage of S3 object lock to ensure that they've got immutable storage to address their storage requirements, as well as their overall compliance strategy. So when we take a closer look, as customers move data into S3 and S3 Glacier storage classes, they're really doing that so they can leverage other insights from their data. And by doing so, many of our customers are actually leveraging other AWS services such as Textrack, Comprehend Medical, as well as other AI and ML capabilities. So as Eric highlighted, once they move the data and archives to S3, that first step is really to look at how to monetize or how to gain insights from that. So here's a sample architecture that uses multiple AWS technologies to help convert unstructured data into something that's structured and usable. So here in this example, we're able to capture text from images using Amazon Recognition. Customers can capture text from scanned documents using Textrack. They can also capture text from transcription using Amazon Transcribe. All this text ends up being processed by Comprehend Medical, which adds the proper clinical context and then stores that data in a secure and compliant Amazon S3 bucket. So customers can have structured, queryable data assets and the overall ability to leverage the breadth and depth of other AWS services like Amazon Redshift, RDS, Elasticache, DynamoDB, and SageMaker. So this is one quick example in the healthcare space. Other industries, other vertical spaces are leveraging very similar approaches to basically to leverage the insights from data once it's in S3. Also taking a closer look here in the broader healthcare space, many of our customers are gaining insights from and extracting data from forms. So here in this example, it's healthcare, but we see this across other industries and other vertical areas. And Textrack is really, it's a service that automatically can extract text and data from scanned documents. So Amazon Textrack goes beyond just simple optical character recognition to really identify the contents of fields and forms and information stored in tables. Textrack makes it easy to quickly and accurately extract data from these documents, forms, and tables, and automatically detects the document's layout and key elements of the page. It can understand the data relationships in any embedded form or table and extract everything with all of its context intact. This means that you can instantly use the extracted data in an application or store it in a database without a lot of complicated code in between. Amazon Textrack's pre-trained machine learning models eliminate the need to write code for data extraction because they have already been trained on tens of millions of documents from virtually every industry, including contracts, tax documents, sales orders, enrollment forms, benefit applications, insurance claims, and policy documents. You no longer need to maintain code for every document or form that you might receive or have to worry about how page layouts might change over time. This is really a great example how customers are leveraging other AWS services really to gain greater insights from their data and from assets that are moving into the S3 storage classes. When we take a closer look, customers are also using AWS storage classes across other industries. A great example of this is in media and entertainment. So taking a closer look here at one of our customers, Nascar. So Nascar is the #1 motorsport in the United States. Taking a closer look at some of their challenges as a growing media business, they were generating about 2 petabytes of archived content every year. This was leading to scaling challenges with their existing LTO tape system. They had thousands of tapes, LTO4, LTO6, in addition to LTO tapes being stored off premises in a disaster recovery location. Managing these tapes was becoming very tedious and really full of risk. They were concerned about running out of tape slots in their LTO library before that next version of LTO was actually released. And so taking a closer look at building out a true archiving strategy, they decided that S3 Glacier archival storage classes could be used to really maximize the value of their digital assets and really allow them to gain new insights on all of those precious assets. Their primary use case really was focusing on the high resolution media files, which represented their highest quality assets that could never be recreated. We're talking about decades of race results and actual race footage. So before AWS, they were creating 2 copies of these assets, one that would stay in their LTO library and another tape that would be shipped off to an offsite location. Using Partner Cloud First Rapid Migrate automation workflow, they were able to migrate petabytes of data to AWS in just about a year. So for their high resolution media assets, they used Lifecycle to move objects to other storage classes to save additional money. So currently they're using S3 Glacier Instant Retrieval to provide that instant retrieval capability for those assets. And after 2 years, they'll move that content down into S3 Glacier Deep Archive to provide that cost-effective price point and ensure that they're effectively storing that copy forever in perpetuity to save even more from a storage cost perspective. So it really highlights the ability not only to really have a cost-effective solution, but really to be able to pivot away from having to manage tape and manage complex process to be able to innovate and drive innovation back into the business. They were able to move away from managing tapes and spend more time developing workflows that support their business as well as please their fans. Another example of a customer using S3 Glacier Deep Archive is Pinterest. So Pinterest manages one of the biggest data sets of ideas ever assembled online. With over 300 billion pins and 440 million users, this really translates to a lot of data being generated, ingested, and analyzed. As part of Pinterest storage efficiency efforts, Pinterest uses Amazon S3 Lifecycle to optimize all their data storage class placement. Pinterest uses S3 server access logging and S3 inventory reports within their in-house storage insights pipeline. This pipeline is part of a key tool set that provides visibility into Pinterest's current storage footprint, the access patterns, and ownership for all data sets. S3 Glacier Deep Archive meets Pinterest storage archival needs. It balances cost, durability, restoration time, providing significant storage savings. Most importantly, when you take a look at how Pinterest is using S3 Glacier storage classes, it's a great example, again, of the constant collaboration with our customers, allowing Pinterest developers to continue to delight their users and focus on that versus having to manage complex storage operations and complex storage workflows. So we thank you for joining us here today. To learn more about AWS Archive solutions, we've got some links you can take a look at our latest solutions, as well as take a close look at S3 Glacier storage classes and keep up to date with our AWS Archiving Storage blog. Thank you for joining us here today. And now we're going to open it up for any questions that you may have.